Hi folks, today what I want to do is go through some of the differences in the valveless pulse jet engine that you're looking at right here versus the ones that you see with the horseshoe style design to them, and why I chose to go with the straight tube design with our intake facing forward instead of curved back around aiming behind us, even though that seems to be the more popular of the designs that are out there. Second of all, I'd like to discuss why you typically see these valveless pulse jet engines in most of the videos out there running on propane, and why most people out there aren't using like a gasoline or any other kind of liquid fuel to run these. The standard Lockwood valveless engine that you see with the horseshoe design produces about 40% of its overall thrust out of the intake, and the reason that is because of the horseshoe shape we've bent in the exhaust pipe. The second you bend that shape in the exhaust pipe, what's the first thing you create? Obviously it's going to be back pressure or resistance in the flow, and that resistance or back pressure in the flow is what creates about 40% of that thrust once again to come out of the intake on that design. So by keeping the exhaust pipe straight in this design, we're not creating the same amount of back pressure or resistance in the flow that's going out our exhaust tube, so we're not going to create the same amount of our thrust out the intake. In fact, as this engine gets up to higher and higher velocities, the volume and the pressure of the incoming air into our intake will overwhelm the exhaust pressures that are coming out of the intake. Let's say we got about 10% of our overall thrust still coming out of the intake at low forward velocities of the engine. Now as we get to higher velocities, that 10% of thrust is going to disappear as it's overwhelmed by the intake forces from all the air being rammed into the front end of our engine. So one of the things that this engine could do that you can't do with the bent style engine is with a simple cone out here in the front with a rod with a spring going back into the combustion chamber with basically a drain from a sink on there as a flame holder. This engine has the capability of functioning like a ramjet engine if you can get it up to the velocities that ramjet engines really start to produce thrust, which is about 400 to 500 miles an hour. So the next part of this is to discuss the fuel system and why you have to use a pressurized fuel on a valveless pulse jet engine. The first main reason for the pressurized fuel is obviously the pressures generated inside the combustion chamber, the expansion chamber here, during the explosion phase of the pulse jet cycle. Those pressures are so high that they'll force any unpressurized or low pressure fuel right back up the fuel line, possibly back into your fuel tank, maybe cause an explosion. So you have to use a fuel system that, I would say for safety's sake, is at least about an 80 to 100 psi fuel system, if not higher, to make sure that that fuel isn't forced back up the fuel line during the pulse jet cycle. Alright, so as you can see there, we're getting this thing running. One of the issues here, why it doesn't seem like it's going to stay running, is because the engine itself is not mounted to the same system I've got the fuel line mounted to. So as it gets running, the engine's moving forward and shifting its position on my fuel line each time, actually stopping the engine running. And as you can see here, they're hard to see in the video, but I've got wires everywhere hooked up to this engine, trying to hold it back so it can't move forward, and it's just stretching my copper wire out. These were really tight when I first started, so it's stretching it out, moving the engine forward, which is great. It means it's producing thrust. It's just very hard to keep the thing running once I get it going because of the mounting system for the fuel.